PrairieLearn is a really cool system that is open source. It's completely free in the sense that it doesn't cost, the code base is open. You can run it on your own servers and it's sort of your own thing. You have full control of the code base and all the features in it. The purpose of it is it's a homework system or a platform where one can do grading of questions that are automatic and also manual. But you can also do homework questions and exams and various other different types of assessments that people are now experimenting with. So it's real time, so students get immediate feedback about whether they get particular questions right or not, and they can do these questions many times, get different versions of the questions, get different variants. It's all randomized, and students are basically able to do this repetition so that they gain mastery of the material or until they reach a certain standard that they're aiming for. Everything's adapted, things are automated, and you get really rich data about how the students are doing in your course. Of course, the best part about this is that there's lots of different question types that exist, and it's all open source. Okay, so to start off this thing, I'm going to show you how you can get registered. So I'm going to share this link in the chat with you all, ca.prairielearn.org. And once you go to it, you will see this button that says PrairieLearn. Don't click the second one, just click the first one, and you'll be asked to log in with your CWL. So I'll go ahead and give you all a second to do that. Just give me a thumbs up in the reactions once you've got that set up. And let me know if anyone's having trouble. You should see something like this. Great, so assuming that you are in, you will now see Enroll Course on the left. So click on Enroll Course and add the XC101 example course from spring 2015. And as well, if you're doing the physics project, you should click on Physics 1112 to add the course. And then, of course, if you're doing the Science 1 course, you'll have your own course that Colin and Andrew created for you. So basically, once you come in, you should have a couple of courses, or up to three courses in your roster. And just to separate why these are separated, explain why these are separated. These are courses, and then these are individual course instances. So for instance, you have something in the summer, something in the spring, something in the fall. PrairieLearn allows you to just duplicate all the content and just run another instance of the course where your settings are kept. And then each content is then separated by an individual course. So what I'll do today is I will walk you through some of the main question types that exist. So let's go to the assessments. This is the place where you're going to see the cool stuff. So there's one that I've created called Phaser Demo, and then there's 15 questions that I've included just to give you a sample of the types of questions that exist. So we'll go through these one by one. Here is a question that's a multiple choice question. A cyclist travels at 2 meters per second for 7 seconds. How far does the cyclist travel? So this would be 14 meters. And then there's also a part 2 of the question. Let's say, it's a different question, but in this case, it's exactly the same, just to kind of show you how you can have multi-part questions as part of one question block. So you can grade this question. You can first save it only, or you can save it and grade it. Okay, so here it tells you that the correct answers were chosen, and then it also keeps track of all of the submitted answers all of the answers you submitted, so that you can reflect and review on why you submitted those particular answers. Let's say you think there's a problem with this question. You can, as a student, click Report an issue with this question, right? And that's really handy. That shows up here so that the instructor can then quickly review it and see if there's actually an issue with it. And if there is, they can update the grading for all of the subsequent questions that people get. So that's a really nice feature that lets you report questions. Okay, let's keep going. I'm going to switch to the student view so that I can advance through these a little bit faster. So here's the first question. You can go to the next question by clicking this, and here it tells you how many points you've earned so far on the particular question. So here's another question, similar, but in a different input. So rather than having multiple choice, you now have a short answer, or a word, sorry, not a word, a numerical answer. So a cyclist travels 8 meters per second for 6 seconds. How far does the cyclist travel? So 6 times 8 is 48. So let's see what happens if I do 6 times 8 and I try to attempt this. So this is not an invalid, this is not a valid input. And if you click Y, it'll say that what it's looking for is a number, okay? It's not looking for math in here. So here we can actually go ahead and type in 48, and then when we grade it, we will hopefully get the question correct. There's a new button here that says try a new variant. So after you finish a question, you get this button, you click a new variant, and then the numbers change. Okay, so now it's 6 times 6, which is 36. And then you can try another variant here, and then et cetera, et cetera. So this is how the questions will be randomized when we create them. You know, many of you have already created a lot of these questions, but this is, when you click try a new variant, it's going to regenerate a new version of the question. And just so that you know what it looks like, I'll show you how to access the text of the question that's actually fully randomized. So if you click on Files, in server.py, that is where the randomization happens. So here we have a generate function, and then what's happening is that a random integer is being generated between 0 and 10. That integer is being saved into a dictionary, and then there's also a time, which is not randomized. The time is fixed at 6 seconds, and then that variable t is also stored in the dictionary. The distance equals velocity times time. This is the answer, and then the correct answer is stored in a dictionary. So here's another question type where we want to mark the centroid of the figures. So here's a triangle and then a square. So here are the objects that we need to use for grading, and here are some interface elements that are just for alignment. So if you want to kind of get an idea of where the halfway point is, we can count the squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we need to go to 7. So this is now my marker for the 7th. 1, 2, 3, 4, 5, 6. So this is the 7th, 7th square. And so my centroid is going to be somewhere here, and then the horizontal direction is 1, 2, 3, 4, and it's going to be here. So my point that I'm going to mark the center of is going to be here. Okay, so now I've marked the center of this square. I'm also going to mark the center of this triangle, which is going to be somewhere. I'm going to eyeball roughly there. Okay, so it says the expected tolerance is half a square grid for position and 10 degrees for angle. The angle doesn't really matter for us for the rectangle, but it does for the square. So we're going to try and grade this and see what we get. Aha, we got it right. So this purple box is the bounds or the threshold for that point. And so we've marked correctly the centroid of this figure, and we get 100% on the question. Okay. So if we try a new variant in this question, nothing's going to happen. It's still going to give us the rectangle and the triangle. But you can imagine if we write our script in a way that will regenerate the figures algorithmically. Let's say it's it's a hexagon, or it's a star, a bunch of other different shapes. You can get different shapes that arise if you cleverly code your questions. All right. Cool. So the next one is this Pythagorean theorem question. You can have a bunch of text here. You can create algorithmically this figure. It'll have a hypotenuse and then a side, and it's asking you to calculate the base. So we would do something like 73 squared minus 55 squared, and then take the square root of all that, 48. So I would put 48 here, save and grade, and hopefully I get that correct. And you get some feedback if you don't get it correct, etc., etc. Now, if you click a new variant on this question, you will get a different triangle. But you notice here when you click new variant, the shape of the triangle actually changes dynamically, right? So as the triangle gets narrower, you get a narrower shape, and these numbers are actually representative or to scale, right? And so you can kind of figure out whether your question is reasonable. So if you put in 40, well, maybe that's close, right? It's not going to be exact, but oh, it is going to be exact. Perfect. So that's good. So we want to eventually generate figures like this for each of our, or not each of our questions, for the questions where it's relevant. And the reason I'm showing this to you is so you can see the possibilities of the system, and so that you can flag the questions where you think it's a good question for some potential randomizing. Okay, so in this particular case, I would actually argue that the amount of code required to randomly generate this particular figure is not that useful, right? Because you're trying to calculate the side, but is it really helpful that the triangle changes shape? Or if we just had a schematic, we can probably build another question that uses the same feature, but it actually makes a difference on whether this triangle is to scale or not. Okay, do you know what I mean? All I'm trying to say is that I would probably not waste a lot of time making this question randomized by having the triangle change shape, because from a pedagogical or from a teaching perspective, the student is not going to gain much benefit if the triangle changes shape. Yes, they're going to get additional value if different sides are chosen each time, right? So if it's a hypotenuse versus the side A or side B, that actually is going to make a difference, because they're going to need to know how to rearrange the equation. That's something that's going to teach them something useful. But having seen the triangles changing shape, it's just a cool feature that doesn't actually add much value to the question. All right, now we're getting into some real physics. So here we've got a pulley system with a block, and the question is draw the corresponding free body diagram, and it asks you to disregard friction. Okay, so we know that this is what the diagram looks like, so we're going to go ahead and draw our free body diagram. We've got these vectors that we can create, that we can rotate, and so we know that gravity points down vertically, so we're going to set our gravity vector there, and then we're also got a tension force that's pulling on the block. So we're going to put a tension force that way, and I think that's everything. So if I try to grade this, it's going to say I got 66%, right? I got two forces right. I got gravity and I got the tension, but I forgot the normal force. Okay. In this particular case, I'm being shown the correct answer, but if I were to do it myself as a student, I would probably not get shown the correct answer, and I would just be told that I got 67%. So what I'm missing here is the normal force, which is perpendicular to the surface of interest, right? So we would do something like that, and that is how the normal force goes in. And then where's the save and grade button? Well, the save and grade button is gone, so I need to generate a new variant, but it's going to generate the exact same one, and you get the idea. That would have been right. All right, so moving on, here's another question, which is a similar pulley system, but here it tells you that there's a mass A and a mass B, and then the gravity is this. What is the force in the cable required for this equilibrium configuration, right? So you would put a number here, and then it would tell you that it has to be in newtons, and the answer has to be within 0.01, right? So let's try the number 50, and that is the correct answer. If you try a new variant, the mass of the block will change, and then we'll try 80. That will also work. Good. Okay, you can also make some more complex questions that are probably beyond the level of first-year physics, but anyway, here they are. You can draw free body diagrams on multiple portions, and you can all auto-grade these pretty easily. And so if I just click save and grade, it'll show you that the way the forces get graded. Oh man, I probably need to put something in here. So I'm just going to put 1 just so that I can show you the answer. So there's going to be one force pointing down, one force pointing that way, and then two forces here, right? So this is how you would answer this question as a student. This question has a high degree of randomizing possibilities, and this would be an excellent question where you would spend a bit of time trying to make different situations and scenarios so that you can basically assess a student's knowledge of this particular concept. All right. Okay, so here's another question with a motion diagram. It's a velocity, or what is it, a horizontal and vertical velocity, and you're being asked whether select all the intervals where the velocity in the x direction is at a minimum. And I'm going to switch to the instructor view so you can see what happens when I try different variants. So here you can see that the points on the graph are actually changing randomly as you click new variant. And this is a hugely powerful feature of PrairieLearn, which doesn't really exist in many other platforms because you can dynamically generate images. And then not only that, but also if you notice here, the x and the y direction are randomized here, right? So you can get questions about x, questions about y, and then you can also get questions whether it's a minimum or a maximum. So if I keep switching this, eventually I'll get a minimum. Okay, maybe that isn't set up yet, but anyway, you get x direction at a maximum and at a minimum. Oh, here we go, at a minimum. So those are the things that are changing. And if we go to the file section in the server.py, we've got to write some Python code to deal with the fact that sometimes it's going to be positive, sometimes it's going to be negative, sometimes it's going to be maximum, and sometimes it's going to be minimum. So we basically have to take into account all of the different things that can happen with a question, and then make sure that our answer is set correctly. Okay. Questions about this? Okay, so I encourage you all to, I'm going to show you a few more examples, but the ones that, resonate with you in terms of the questions that you've seen already that you think would benefit, I encourage you to look at the server.py for them and to see if you can kind of make sense of what the code is doing, right? The nice thing is you can copy that code and put it into a Jupyter notebook, and you should be able to run it normally. All right, back to student view. We are on which question? This one. Here's a nice one. If you have an area for the math questions, for the people doing math questions, here's a question. Find the area A for a region bounded by 1 minus x squared. Okay, so this plot will regenerate every time you click new variant, right? Which is nice. So here's 1 minus x cubed, 3 minus x to the 5th, and these are essentially you're trying to take the area under this curve by calculating it. And this is nice because you can set bounds on what the polynomial has to be. So I think it's something like x to the 6 is the maximum polynomial, and this number varies between 0 and 9. So you can sort of generate. This one's a pretty easy one, I think, to generate. Oh, maybe it's not that easy, but here, so yeah, that's right. So the code for the question is very easy because it's just randomizing the. Oh, here we go. So the exponent is going from 2 to 5, and the constant that's being subtracted from the expression is going from 1 to 10. And you just need to evaluate this, right? So this is pretty easy. The hard part, or the more complex part, is that there's an image that needs to be created every time a new random question is created, right? So here we are going to create a new image file every time a new variant is generated. All right, the next question is a circuit one. This is actually a broken circuit, but you can imagine a correct circuit and then asking you what the equivalent resistance is of the circuit below. Here again is a dynamically generated figure where the question changes. So one is the equivalent resistance, one is the current. There's various different types of questions you can ask here, randomized in the same way. And then here's a question that I created. If you have 3 blocks and you're pulling on it, rank the forces in each one, right? So that's another question that you can create. And here, the masses of each of the blocks can change in size. Or you can just leave it as all algebraic. All right. So here we want to draw a vector. So this is similar to the drawing a normal force question. We want to draw a vector. So somewhere, so this is 0. We want to go to 150. So that is somewhere in here. Hopefully I get my quadrants right. You just need to draw the vector, and it's incorrect. So 150 is actually, oh, in the other opposite direction. Yeah, my bad. Yeah, the vector should be pointed in quadrant, in this quadrant. If you are a math person, you're probably laughing at me, but anyway. Nice thing is, every time you regenerate a question, the angle changes. All right. Okay, so this is one of the cooler questions that Dr. Bobowski created. So Jake teaches the second term physics course, but he is sort of experimenting with the PrairieLearn platform as well. And here he has a velocity versus time graph, and they're actually asking us to sketch the acceleration versus time graph. So you can have different shapes of a thing here. You can have lines, you can have curves, and so you can essentially draw your own shapes. Obviously, this is not the correct answer, but I'll show you how the question is graded. So this is the correct answer here. You need to get the bounds of the straight line correct. So here's the green box that shows you what the tolerance is. So your circle point has to be touching or inside that green box. And then the other thing, there's another version of this question that lets you get the curves, and that's actually the next one, I think. Yeah, so here's the velocity versus time, and you're trying to get the position. So here you can draw some curves, and then you can grade it. And then it tells you that the curvature point here has to be at 6, right? And then it needs to be inverted like that. And again, this is another auto-generated question. All right. Other things you can do, you can upload files here. So if you have a coding question and you want them to write a Python function, students can upload a file, and you can control the extension of what needs to be in there. And then, yeah, so it can run the file, it can run the code and see if it generates the correct output or not. All right, so that is it. Any questions about any of the problems that I showed, or any comments or suggestions of new things that you are thinking of that might be possible now that you know what PrairieLearn can do?
I had sort of a question that came up while I was working on throwing together a problem about integrals. As I know, PrairieLearn in the server.py file will let me use SymPy to work with integrals and stuff. And I guess a question I kind of had is, say I have some problem, I'm being mean, it's a particularly difficult integral to calculate, and it's maybe even something that takes SymPy a while to calculate. Then will I run into issues if I just put in my code like simpy.integrate instead of integrating it by hand? Because like, will PrairieLearn try and do that every single time? Like, I guess I'm asking how often it executes the server.py file and how
Okay. So there's two
efficient it
questions
needs to
there.
be.
One is, how often can you generate a new question? Uh,
Mm-hmm.
so that is something that you can set as a user. So for instance, from a pedagogic perspective, you don't want to have students keep trying questions again and again and again.
Yeah, yeah, yeah.
You can set a limit of, let's say, a new question will only be generated every 5 minutes, right?
Okay.
So that's one restriction that you can put on the generation of questions. I think the second question we're asking is whether the input, so you can control what the user inputs, right? So one of the questions I showed at the beginning, I put in like 8 times 4, and it didn't accept that, right?
Hmm.
Because it actually expected a number. So you have fine control over what the expression looks like that gets graded, even if it's a valid SymPy or a valid algebraic expression. You as a question creator can say, no, I don't want that. I want a number, even if it's a question that requires symbols, right? So you can design your way out of anything you can think of. Of course, the problem is you have to really test it, right? So if you have a question that uses symbols, but at the very end you coded it so that it expects numbers, well, that question doesn't make sense. So students are never going to be able to get it right. So they're going to probably create an issue, and then that's going to get sent to you.
Okay.
Okay.
Thanks.
Anyone else have any comments or questions? All right. So the XC 101 course has a couple hundred different problems. I just chose some representative ones here, but there's also some symbolic problems that are useful. So here it says y equals ax plus b, assuming that a is not equal to 0, solve for x. So you can do things like y minus b divided by a, and then I will grade that for you. You can take derivatives, you can take integrals, you can have all sorts of different symbolic expressions in your questions. So all of this is possible. Okay. Cool. I will stop there and just let you play around with it. If you have questions, please do let me know. I haven't gone through much of the interface that you don't really need to know about, like how to set time limits for assessments and things like that. Like that's all possible in here, but it's not something that is useful for us at the moment. So first, the interface. The top bar in black is the instructor or the admin interface. You can switch to the student view and you'll get a different interface, but here you'll have access to a subset. So obviously these are the assessments the student has access to, and then these are the grade book where they can see all their grades. This instructor student view will let you swap between the two. And then when you are an instructor, you get access to a bunch of other options as well. You have access to access different courses, the issues in the course. So these are any problems that exist with your questions. You have the full questions that exist in your course. And then there's this new button called Sync that PrairieLearn is all based on Git. Okay, that's one of the reasons why I really like it. Everything is versioned, everything is controlled by Git. And the difference is that in PrairieLearn, the Git, it's not on github.com, it's on github.ubc.ca, which is a special version of GitHub. It's called GitHub Enterprise that UBC has a license for. And the reason for this is because there's student information on here, and because of privacy laws, we cannot have that hosted on the github.com server, which has data in the United States and basically outside of Canada. So we have our own GitHub instance, github.ubc.ca, and this is a repository, PrairieLearn, phys112.get. So everything is versioned on Git. That means that there are two ways that you can edit the course. You can go like command mode and clone the repo to your computer and then start editing JSON files and text files and then push that up to the cloud. So that's one way, and then the other way is, of course, to use the interface here, the user interface elements here. The problem is that if you ever edit a course on the GitHub repo and you push it, you need to pull from there, because PrairieLearn is just like an application. Just pretend it's a user, whenever there's changes that you make, you need to pull it from the central repository. And so you need to click this button called Pull from Remote Git Repository. And then okay, so this is the components of a question, and you will see this is familiar. It's similar to what our template is, and what we are doing. And Science 1 people, please close your ears for a second. This is not relevant to you. But what we're doing is we're creating questions in Markdown format. And you'll recognize that this server portion is very, very similar to what's going to end up in this file. So what we are doing is we're building on top of the PrairieLearn interface. We're writing all of our questions in Markdown. And then we have a script that Graham's writing that's going to take this part of this of our Markdown file and then strip out everything else, put this into a file called server.py, and then the rest of the question will get parsed. So this is a header. The distance traveled will go into this JSON file, the title, and then the topic will go here, and the tags will go here. Okay. So what we are trying to do is we are trying to, rather than having 3 different files for each question, we're going to write everything in one file and then have a script that will automatically take components of that file and put it into the right spot, right? The hardest of this is, of course, the question.html, because there's going to be a whole bunch of HTML tags that are needed that we need to add. So what we are doing is we are just writing our questions in pure Markdown, and we're relying on an algorithmic solution to fill in all of the components of these tags that need to be put in.